Assalamualaikum dear viewers, Shoaib and Dayo is here, and today's lecture is related to the transformer connected with the DC supply. Means we are going to analyze or observe the behavior of the transformer when connected with the DC supply. So as you know that the working principle of the transformer is totally depend upon the law of the electromagnetic induction process. The transformer has the two coils, the primary coil and the secondary coil. The primary coil is connected with the AC supply and secondary coil is connected with the load side. And the definition of the transformer is that it is the electrical piece of the equipment which is used to raise or lower the amount of the voltage according to the decrease or increase corresponding with the current at the constant power and the constant frequency. So let's discuss the today's topic with the transformer behavior working on the DC supply. So a transformer cannot raise or lower the amount of the voltage at the DC because you know that the direct current supply has no any kind of the variations with respect to the time. It has the steady state operation. So when rated DC voltage is applied, if you can see the diagram of the transformer, the primary winding of the transformer is connected with the DC supply, and if you are connecting the DC voltage to the primary winding of the transformer will draw the steady state current from the supply, from the main DC supply. So what happened? Hence the constant magnetic flux is to be produced which has no any changing. Okay. So for the induced EMF operation, we need to change the flux with respect to the time according to the law of electromagnetic induction. Whenever a flux is linking with the coil, it changes and EMF is induced in the coil. So this was the fundamental definition of the Faraday's law of the electromagnetic induction, and already we have discussed in our previous lectures. Okay. So if you are connecting the DC supply with the primary side of the transformer, then no induced EMF you will be observed on the primary side, okay, and the secondary side, because EMF, for the production of the EMF, the flux should be changed with respect to the time. d phi over dt, lines of the cuts of the flux with respect to the time should be happen. If that will be happen in a transformer or an electrical machine, then EMF will be induced in that coil. So induced EMF should be changing the magnetic field, magnetic flux linking with that winding. Therefore, a transformer does not operate on the DC supply. The transformer does not operate on the DC supply because it has no any variation with respect to the time. It has the DC supply, means the direct current which has the steady state operation. Okay. So in fact, connecting the DC supply to the primary winding of the transformer can be dangerous one. Why? Above these two diagrams shows the DC supply which is connected with the transformer. Okay. Now, since no induced EMF is produced to oppose the cause which is given to rise, according to the Lenz's law, the direction of the induced EMF is opposed that cause which is given to rise. Obviously, there is no EMF which is to be induced in the transformer, so there will be no any opposition from the secondary side of the transformer. So what happened? The primary will draw more current, so that may cause overheat the windings of the transformer, and maybe transformer primary winding will be burned out. So if we have to clear this concept regarding these two calculations, so this will be easily cleared from this calculation. So this case is the AC supply which is connected with the transformer, and this case is the DC supply which is connected with the transformer. So according to the Ohm's law, I is equal to V over R. If we have a current, we have to find out in the circuit, I is equal to V over R. If the resistance, if you are connecting the DC supply with the transformer primary side, so what happened? The resistance is very small, so the current on the primary side will be more, so that it can be very dangerous for the primary winding of the transformer, or it may cause the overheating of the windings of the transformer, and transformer primary winding may be burned out. Okay. So if you are connecting the AC supply with the transformer and the DC supply, compare both cases so that how the AC supply, when it is connected with the transformer, can reduce the amount of the current which is to be drawn from the primary winding of the transformer. Okay. So if we have a primary voltage on the primary side which is a 230 volt, and resistance is the 10 ohm, and inductance, suppose we are taking the 0.4 Henry. Okay. Now we have to calculate the impedance in the circuit. Now impedance in the circuit is that you are if we have an inductive circuit, so it will be the R square plus XL square, inductive reactance plus sum of the inductive reactance and plus resistance. So we can easily find out the impedance from this formula. And also inductive reactance can also be calculated with the 2 pi FL. We have the value 2 multiplied by pi 3.14, frequency we have a 50 Hertz, and L already we have a even. So here we are obtaining this 125.67 ohm, which is the XL value, and putting these values in the R square plus XL square, then we have got the impedance value which is the 126.1 ohm. Okay, so this is the impedance in the case of the AC supply which is connected with the primary winding of the transformer. So calculate the current over here according to the Ohm's law. Z is equal to V over I. Okay, Z is equal to V over I. So I is equal to V over Z. We have already voltage value 230 volt is the voltage, and impedance is that 1.26 126.1 ohm is that our impedance value. So current in the case of the AC supply is 1.282 ampere. Okay, so this is the current which is to be drawn by the primary side of the transformer, primary winding of the transformer from the main supply which is connected with the transformer. Now let's see this case. When DC supply is connected with the transformer, now we have same value 230 voltage, resistance is the same. Now in the case of the DC circuit, the frequency is 0. If there is frequency is 0, then what about your inductive reactance or the impedance factor? 0. Because if the frequency is the 0, then there will be no any changing in the magnetic flux within the winding of the transformer, since no EMF will be induced in the windings of the transformer. So frequency is the 0, then whatever, only we are taking the resistance factor in the windings of the transformer. So resistance is here 10. Now according to the Ohm's law, I is equal to V over R. So we have V 230 divided by only just taking the resistance 10, 23 ampere. Now compare both values. 1.82 ampere is the current which is produced in the AC supply when AC supply is connected with the primary winding of the transformer. So this is the current which is to be drawn from the transformer primary winding from the main supply, and this is the primary side current in the case of the DC circuit when the DC supply is to be connected with the transformer, which is a 23 ampere. So if 23 ampere current is to be drawn from the main supply, so obviously the primary winding of the transformer may burn out, or will why burn out? Because it will overheat the windings of the transformer, and they may cause the burning of the primary coils or the primary winding of the transformer. So this was the comparative case of the AC supply which is connected with the transformer primary side, and the DC supply which is connected with the primary winding of the transformer. So this was the lecture regarding the transformer when it is connected with the DC supply, because for the production of the EMF, the flux should change with respect to the time, and induced EMF should be produced with respect to that when flux is changed with respect to time, according to the Faraday's law of electromagnetic induction. And if the transformer is connected with the DC supply, so since no EMF will be induced in the secondary side, because there will be no any opposition in the primary flux, no changing will be produced in the primary flux, so it may cause the overheating of the primary winding of the transformer, because primary will draw more current from the supply, because only the resistive factor if we are taking in the DC supply, because in the DC supply there will be no any impedance effect. If we are taking just resistance factor, resistance is very small, so I is equal to V over R. If the resistance is very small, according to that current will be too much greater, because current and the resistance are both are inversely proportional to the each other. So this was the lecture regarding the transformer when it is connected with the DC supply. I hope that you have understood the today's lecture, and at the last, please don't forget to subscribe my YouTube channel Shoaib for more informative videos related to the electrical engineering area. Thank you.